Welcome to EDU World Space.
Okay, chapter 4, problem number 15. We have a force function for this rocket. It's a plus bt squared. And we have the force at times 0 is 100 newtons, the force at times 2 is 150, and we are asked to solve for a and b, including their SI units. So first off, the force at times 0 is equal to 100, which is equal to a plus b times 0 squared. So we see that a is simply equal to 100 newtons. And plugging that in for the force at time 2 now, that's going to equal 150 newtons, which is equal to a, which was 100, plus b times now 2 squared. So then we subtract off the 100, do some algebra. We've got 50 divided by 4 is equal to b, and that's going to be, let's see, the units here, newtons over seconds squared. So we've got 50 over 4 is 12.5 newtons over seconds squared is equal to b. So we get our complete equation. The force at any time t is equal to 100 plus 12.5 t squared, and we'll be using that in the next part. Okay, so in B1 here, using that same force function that we just derived, they want to know what is the acceleration of the rocket at 0 seconds when the rocket is just fired. So quick free body diagram here. Force is acting on the rocket. We've got gravity, mg, going down, and we're going to have this force from the rocket going up. So going to Newton's second law, we have the net force is equal to the mass of the rocket times a. And let's make that side note. The mass of the rocket is 8 kilograms. So the net force is going to be F minus mg is equal to ma. Plugging in t equals 0 to our equation here, we've got a force from F of 100 minus 8 times 9.8 is equal to 8 times a. Dividing both sides by 8, we get the acceleration, and that is equal to 2.7 meters per second squared. For B2, they want to know what is the acceleration of the rocket now at 3 seconds. So free body diagram and the Newton's second law all look the same except our F, magnitude of F, we're going to plug in 3 to the t. So we're going to have, for F, 100 plus 12.5 times 3 squared, still minus the mg, 8 times 9.8, and that's still equal to the ma, 8 times a. So again, we're going to solve for a, and we end up this time with 16.8 meters per second squared. And now in the final part, we're just firing this rocket in empty space, so now our free body diagram doesn't have mg anymore, it's just got F. And they want to know what is the rocket's acceleration going to be when 3 seconds after we fire the rocket. So again, we're going to have that force at 3 seconds, which is going to be 100 plus 12.5 times 3 squared. And then we are going to just divide that by the mass. So if that's F, that's equal to 8 times a. So dividing both sides by 8, we get the acceleration in empty space, and it's going to be 26.6 meters per second squared. That's it.